Hey Stella, I gotta ask, 48 hours? Really? Train a reasoning-capable LLM in one weekend? I mean, that sounds almost impossible, doesn't it? As a business guy, I'm thinking, no way.
Alex, I know it sounds wild, right? But yes, absolutely. And that's thanks to NVIDIA NeMo. It's kind of revolutionizing how we approach LLM development. We're talking about taking a powerful base model and, well, fine-tuning it to reason deeply in just 2 days on a single GPU. It's really incredible.
Wow, a single GPU. That's a game changer for a lot of smaller businesses, I imagine. So what exactly does reasoning capable mean in this context? Like, it's not just generating text, but actually understanding and solving problems?
Exactly. We're talking about models that don't just regurgitate information, but can actually think through a problem. Like you saw in the video. It's about giving them the ability to, follow a chain of thought, do complex math, or even write code by breaking down the steps. It's not just about speed, but about intelligent problem solving. It's totally empowering for developers, honestly.
Okay, so that's fascinating. But if you're training something so complex in such a short time, the data must be pristine, right? Like, where does this magic data come from, and how do you even prepare it for something like this?
You hit the nail on the head, Alex. Data is absolutely critical. We start with something called the Llama Nematron pre-training dataset. It's a huge dataset, over 32 million samples, covering everything from math and coding to science and general chat. Now, the trick is we don't just dump it all in. We use NeMo Curator to filter and extract the most relevant examples. And this is where the reasoning part really comes in.
So you're curating the data specifically for reasoning. Is there a special way to, like, teach it to think?
Yes, precisely. Each sample has an input and an output, but crucially, it also has a reasoning flag. If reasoning is on, the output isn't just the answer. It includes the model's detailed thinking process. It's like a step-by-step trace of how it arrived at the solution. If it's off, you just get the direct answer. We also apply a consistent chat template, so the model learns to interact in a standardized way. Plus, we sort the data by output length, which is a form of curriculum learning, gradually increasing the difficulty for the model. It's really smart, helps the model build on its skills. Oh, and we filter out non-English text too, using fast text.
That's sorting by difficulty. That's really clever. It makes sense, for it to learn like a human would. So once you've got this perfectly curated data set, what happens next in the actual training process? Are we still talking about a single GPU, or do you need a supercomputer?
Great question. And yep, we're still talking single GPU for this specific recipe. We use the NeMo framework, which is a comprehensive suite for LLM development. The video specifically highlights training a LoRA adapter, which is a parameter-efficient fine-tuning method. It's verified on a single H180 GPU and takes about 48 hours for 2,000 steps. Full fine-tuning, that's like training the entire model, that would need more GPUs, like 8 of them, but it's faster at 12 hours.
Fascinating. So it's about efficiency then, using the LoRa adapter. And what about the actual implementation? Like for a business person looking to get into this, is it something you need a PhD to set up?
Not at all, Alex. That's the beauty of NeMo. You start by launching an official NeMo framework Docker container, so all the necessary environment and tools are pre-configured. Then you convert your base Hugging Face model into NeMo format, which is just a utility script. After that, it's about defining parameters for your data loader, setting up the trainer, optimizer, and logging, all within a clear, well-documented notebook. It really streamlines the entire process, making advanced LLM training, well, genuinely accessible. The training progress, you can actually monitor it with TensorBoard, which is super helpful.
So after these 48 hours of intense training, you've got this reasoning model. What then? Does it just sit there, or how do you actually put it to work in the real world? Like, what's the deployment story?
That's where the real excitement begins. Once trained, we export the LoRA adapter to the Hugging Face format. This is a crucial step for deployment because it makes the model compatible with popular inference frameworks. And for easy, scalable deployment, we use NVIDIA NIM, which is short for NVIDIA Inference Microservices. It's basically a set of pre-built microservices that lets you deploy and run AI models in production with incredible efficiency.
Okay, so NVIDIA NIM makes it easy to actually use the model. You showed it in the video generating Python code for that Pygame animation, right? That's a pretty cool example of its reasoning.
It truly is. It wasn't just, spitting out random code. It had to understand the requirements: big, slow red square, small, fast green square, bouncing off walls, bouncing off each other. That's complex reasoning in action. For businesses, this means you can fine-tune LLMs for highly specific tasks: customer service bots that can solve problems, sophisticated code generation, scientific research assistants, you name it. The possibilities are really endless, and it's all, much more attainable than people might think. It's a powerful tool for innovation. And that wraps up our deep dive into training reasoning-capable LLMs in a weekend. It's pretty mind-blowing stuff.
Absolutely, Stella. Thank you for breaking that down for us. It really changes my perspective on what's possible with AI development right now. So much more accessible than I thought.
You got it, Alex. Always a pleasure.
To all our listeners, if you enjoyed this discussion and found it helpful, please remember to like, share, and subscribe to our podcast. And for more amazing insights into the world of AI, make sure to check out Frank's World of AI over at franksworld.com. We'll see you next time.